Hello everyone and welcome back to day 4 of learning Python from scratch, and today we are going to learn more about dictionaries from where we had left in the previous session. So today we are going to learn about how we can change items in dictionary and add items, remove items, loop through dictionaries and further stuff like that. So without wasting any time, let's get started. Okay, so you can change the values of specific item by referring to its key name. So in the dictionary, if you remember that we had some keys and we had some values. So it's a key value pair. So we can change the value of this specific item by referring to its key name. For example, here we have the dictionary car. We can change the value of its key, for example, brand, by just taking the key and changing its name. For example, we can say car and then we can say, for example, brand, and we can say something else. For example, instead of Ford, we can say something like BMW. Okay, now if I print car, I should get the new key value pair in this. You can see brand BMW, model Mustang, year 2020. Okay, now the another way is to use the update method. So update method will update the dictionary items with the items from the given argument. So instead we can also pass an argument to change the value of the dictionary. For example, we can say something like car dot update, and then we can pass in a key value pair. For example, we can say year, that has to be in quotes, and we can set its value to something like 2026. Okay, and now if I run this, we should get 2026 here. Let's run it again. Okay, that didn't work. Let's see why. Okay, because we are not printing the car, it's taking the value from here. So just shift this print statement after the update statement, and now if we run the code, you can see that we are getting year 2026. Next is adding more items to the dictionary. So we can add items by using a new index key and assigning a value to it. So what we can do something like, okay, we'll do it before the print statement. So we'll say car dot, sorry, car, and then we can use the square brackets to access the key. And then here we can say something like color, and we can set its value equal to red, like this. Now we have another key value pair in the dictionary named color, and its value will be red. Let's see that in action, and you can see that we have color red. Now next is removing the items. Hi, how are you doing? So if so, please tell me in the comment, how are you doing, guys? Okay, so the next is how to remove the items from the dictionary. So there are several methods to remove the items from the dictionary. For example, there's a pop method which can remove the item from the dictionary using a specified key name. For example, if you want to remove the color, we can say car dot pop, and then we can specify the name of the key, for example, color, like this. And if we run this file, you can see that we have the color gone. Okay, so something like that. The another way is we can use the pop item method. The pop item method removes the last inserted item. Okay, and if you're using Python 3.7 or before, or basically the versions before 3.7, so basically 3.6 and before, then a random item is removed. So remember this and use this with caution, that if you're using pop item with Python 3.6 or earlier versions, then it will remove any random key value. So if you're using a latest version of Python, then you don't have to worry. It will just remove the last added item. So if I run this here, so let's see car dot pop and sorry pop item. And if I run this, let's see what gets removed in our case. So you can see that the year has been removed because the year was the last key value pair which we had added in our dictionary. Then we have the del keyword. The del keyword removes the item with the specified key name. Okay, so we can say something like similar to the pop method, I guess. So we can say del car and then we can specify the key name, for example, model, like this. And then it will remove that particular key value pair. If you run this, you can see that we are just left with brand BMW. Now the del keyword can also delete the dictionary completely. So we have to use this with caution. So if I say just del car, it will just delete the complete dictionary. Okay. And if we print car, this will give us an error because car no longer exists in the memory. So if I say this, you can see that the name car is not defined. Okay. Instead, what we can do is we can use the clear method also. So when we use the clear method, it will just empty the dictionary. So if I say car dot clear, it will just delete all the key value pairs in the dictionary, but it will not delete the complete dictionary from the memory. So we'll have an empty dictionary after using the clear method. So if I run this file, you can see that we will have an empty dictionary here. Okay, next is looping through the dictionaries. So you can loop through a dictionary by using a for loop. Now, similar to all the iterables, the lists, the tuples, and the sets. So you can use the for loop to loop through the items. So we can just use the for in loop for looping through all the items in the dictionary. And we can access the keys through the square brackets. So for example, we can say for X in car, and then we can print something like car X, like this. Now since right now the our car dictionary is cleared, so we'll not get any output, so I'll just comment this out. And then if we check here, you can see that we are getting BMW and Mustang. So basically it gives all the values of every key in that particular dictionary. Now we can also use the values method to return the values of the dictionary. So instead of using the bracket syntax, we can just say car dot values like this, and then we can just print in the variables. And this is the same. We will get the same output. We'll just get the values of all the keys in the dictionary. And if we want to loop through all the keys and the values together, Then we have to use the items method. So if I use items like this, items, and for that we have to use two variables here. So instead of x, we have to say x comma y. So x will contain all the keys and y will contain all the values. So I can say x comma y, and then we will have all the key value pairs in the car. So you can see that we are getting brand BMW and model Mustang. Now you cannot, now let's see how we can copy a dictionary. So you cannot copy a dictionary simply by typing basically car is equal to car one, because that will just create a reference to the initial variable, and the changes made in the car will automatically be made in car one as well. So if I say something like this, I'll just comment this out. Now I cannot do something like car equal to, or basically car 1 equal to car. We cannot do this, because if you're doing this, car 1 is just creating a reference to the original dictionary car. So for example, if I change something in the car, for example, let's add a new key value pair in the car. So I'll just update the car like this. Okay, so you can see that right now we just have two key value pairs in the car, the brand and the model. So I'm adding the year. Now, if I print car 1, we will get the same values in car 1 as well. So if I do like this, you can see that even in car 1, we are getting the year. However, we have just made the changes in car. So that is because we are just creating a reference through the statement. So while copying, we cannot do this. If we want to create a if we want to create an actual copy of that variable in that memory, or the dictionary in the memory. So to create a actual copy of the dictionary, we need to use the copy method. So what we can do car1 is equal to car dot copy like this. Now this will just create a copy of the car variable or the car dictionary in another dictionary named car1. So any changes made to car will not be reflected in the car1. Let's see that in action. So if I run this file, you can see that the year is not present in car1. Then we can have a nested dictionary. So a dictionary that can contain another dictionary is called a nested dictionary. So I can have a dictionary which contains other dictionaries. For example, let's take this example here. So you can see that we have a dictionary called My Family, and inside the My Family dictionary, we have three dictionaries, Child 1, Child 2, and Child 3, and each have a key value pair. So these are exactly similar to objects in JavaScript, the way we create objects in JavaScript. So we can do all these kind of stuff. So the another way of doing that is that we can create the three dictionaries separately like this. So here we are creating three dictionaries, and then we can create another dictionary, My Family, and we can create use this syntax to create the other three dictionaries in the same dictionary. Now to access the items in a nested dictionary, we have to use two square brackets. So for example, we can do something like this. And now we have, if we print this, we will get the name of the child 2, that is Tobias. Okay. So if I run this file, you can see that we are getting Tobias here. We can also loop through the dictionary by using the items method. So what we can do is we can say something like this. So here we are creating a for loop x an object in my family.items. So basically my family contains three dictionaries. That is the concept of nested dictionaries. And here we are printing the first item, basically the first dictionary. And then we are creating another loop in the values. So values are basically these. So here we are creating another loop, and here we are creating the uh, the variable as well as the value of that variable. So if I print this, you can see that, okay, we have not saved it. Okay, now if I run this, you can see that we are getting the names of all the dictionaries in that nested dictionaries. Type yes in the chat. Type yes in the chat box if you understood this concept, if you understood the concept of nested dictionaries and how to access each variable in the nested dictionary. Okay, next we have some other dictionary methods as well. For example, set default. So we can use the set default method, which will return the value of a specified key. And if a key does not exist, then we can insert the key with a specified value. So that will be the default value of the dictionary. And rest all functions, I think we have covered. So that completes our dictionary. Now let's move on to conditional statements or if-else statements in Python. Now if-else, pretty similar like the way we do in JavaScript. Let's comment this out. Okay, so it supports the basic usual conditions, for example, equals, not equals, less than or equal to, greater than or equal to, something like that. Now, these conditions can be used in several ways, most commonly in if statements and loops. An if statement is written using the if keyword, of course. So what we can do is we can create a simple example like this. So we have a equal to 33, b equal to 200, and if b is greater than a, which is the case here, we will get print b is greater than a. As simple as that. Now, how the if statement works, the if statement evaluates a condition, an expression that results in true or false. If the condition is true, the code block inside the if statement executes, and if the condition is false, then the code block is skipped. Okay. Now, we have already discussed that Python depends on indentation. So writing this will work, and if I just remove the indentation, you can see that we are getting an error. So this will not work. This you have to remember while writing any code in Python. Now we can write multiple statements in the if block provided they have the same indentation. So like you can do another statement like this, whatever, like b is 200, something like this, and they both will be executed if this statement is true, which is true in this case. So both statements will be executed. Now we can also use Boolean variables directly in the if statement without any comparison operator. So for example, if we create something like this, if logged in is equal to true, if is logged in equal to true, then we have not used any conditional statement here. We are just saying if is logged in, and then we can print welcome back, something like that. Now, as we have discussed earlier, 0, empty strings, none, these are all falsy values in Python. So these will be treated as false, and everything else will be treated as true in Python. Okay. Now let's come on to elif keyword. The elif keyword is the Python's way of saying if the previous condition is not true, then try this condition. The elif keyword allows you to check multiple expressions for true and execute a block of code as soon as one of the conditions evaluate to true. So it is exactly similar to writing else if in Python, in JavaScript. So in Python, we say elif. In JavaScript, we used to say else if. Okay, so let's take the example like this. So we have a equal to 33, b equal to 33, and we are saying if b is greater than a, then we have to print this. Otherwise, elif is otherwise a equal to b, then print a and b are equal. Now we can have multiple elif statements. So for example, let's see this example. So here you can see that we have created a variable score. Now we have created multiple elif statements. So this is the correct syntax. If we want to check for multiple conditions, we can use multiple elif statements. Now apart from elif, we also have the else keyword. Okay. So the else keyword catches anything which isn't caught by preceding conditions. So if nothing has been caught by if and elif, then it will be caught by the else condition. So what we can say here, like here we can say else, and we can print, for example, something like incorrect input. So for example, if someone has entered a string or some words in the score field, we can do something like that. We can use the else keyword to display this particular condition, and it will be executed when all other conditions have failed in the if-elif chain. Now we can also use else without any elif statement, so we can just say something like this as well. This is also perfectly valid. Now there's also a shorthand if. So if you have only one statement to execute, you can put it on the same line as in the if statement. So this is nice. So you can say something like this. So here you can see we have just one statement, and if we have to just check for one statement, we don't need to do it in other line. We can create it in the same line. So this is another way we can write the if statement. Please write yes in the chat box if you understood this, or if you're learning Python for the first time, just let me know in the chat box. Or if you already know Python, please let me know. Now, the next is that we can also assign a value with if else. You can assign a one line if else to choose a value and assign to the variable. So like you can do something like this. So if a is equal to 10, b is equal to 10, we can see bigger is equal to a if a is greater than b, else b. So this is something, let's run this. So you will have a better understanding. You can see bigger is 20. So this is a way how which we can assign a variable to assign a value to a variable using the if statement. So here you can see we have created a variable. You can see we have created a b variable, and we have said bigger equal to a, and here we have put the condition. So bigger equal to a if a is greater than b. Now a is not greater than b, so that's why else b. So bigger will be b. If you understood this concept, write yes in the comment box or the chat box. So this is a new syntax which if you're learning Python for the first time, it'll be important for you. So this is a shorthand which you can write in if else statement. Now we can also do logical operators using the if else statements. So for example, if we have to check for multiple conditions, for example, something like this. So here we have A equal to 200, B equal to 33, C 500. Now if A is greater than B and C is greater than A, we have already learnt about the precedence of operators in the previous live streams. So you can do something like that. We can use logical operators to daisy chain multiple conditions. Now we also have a nested if, so we can have a if inside a if block. So what we can do something like this. So if x is greater than 10, then print above 10. Now this if statement, since it is in the same indentation block, so it is nested inside the previous block. If x is greater than 20, then print also above 20. Otherwise, we have to print not above 20. So we can do something like that. And we can create, of course, multiple levels of nesting. So you can nest as many levels deep as needed. But of course, creating multiple levels of nested if else will make your code harder to read. Now, if statements cannot be empty, but if for some reason you have an if statement with no content, put in the pass statement to avoid getting an error. This is important. So, if statements cannot be empty in Python, if for some reason you have to keep it empty, you have to use the pass keyword. For example, let me show it to you. You can do something like this. For example, if I don't want to do anything, if B is greater than A, we have to use the pass keyword to avoid an error, because if I just keep it empty, you can see that we are getting an error. Okay, so the if blocks cannot be remain empty in Python. Now, the pass statement is useful in several situations. So, when you are creating code structure but haven't implemented the logic yet, or when a statement is required syntactically but no action is needed, or as a placeholder for some future code. So, these are the conditions where you would require a pass statement. So, this is pretty important to understand that you cannot have an empty if statement in Python. Okay. Now let's come on to the match statement. The match statement is used to perform different actions based on different conditions. Now, instead of writing many if else statements, you can use the match statement. So it is something like the switch case in JavaScript. So the way we used to write switch case, similar, we have match case in Python. So let's see how it works. Here is the example. So you can see that we have created a variable day, and then we can do match day, and then we can define different cases and print different values on it. Now we can also provide the default value using the underscore as the last case value if you want the code block to execute when there are not other matches. So again, this is different from other programming languages. In other programming languages, we use something known as the default keyword. Here we use the underscore. So we can do something like this. So we can do case and then we can say just an underscore. So this means default. So here I can say this means default like this. Now we can also use the pipe character as an OR operator in the case evaluation to check for more than one value match in one case. Okay, interesting. So instead of writing like each case, if you want to check for multiple cases and you want to execute the same block of code, you can do something like this. So you can use the pipe operator to check for multiple conditions at once. So you're matching the day, then case 1, 2, 3, 4, 5, we can say today is weekday, otherwise I love weekends. You can add if statements in the case evaluation as an extra condition check. Okay, not only that, we can add the if statement inside the case as well. So we can do something like this. You can see month equal to 5, day equal to 4. Now we are checking for all the 5 days. If month equal to 4, a weekday in April, and then again we are checking, and if month equal to 5, then we are getting a weekday in May. Otherwise, this is the default value and we are saying no match. Now let's come on to loops in Python. So Python has two primitive loop commands, the while loop and the for loop. Again, we have already seen for loop multiple times. Now while loop is similar to other programming languages, so similar to JavaScript or any other programming language. We simple have a while condition and then we have an iterator, and when till and this loop runs till the time the condition is matched. So as simple as that. If we want to break from the loop early, we can use the break keyword. So we can do something like, for example, if we want to break the loop after 3 iterations, we can do something like this. Now this is giving me an error because I am using incorrect indentation. So now this. So while I is less than 6, if I'm checking if I equal to 3, then just break. So the loop will end here. We can also use the continue statement if we want to skip a particular iteration. So instead of break, we can just say continue, and it will just skip one iteration when I will be equal to 3. Okay, let me just show it to you. Okay, so what wrong? We did something wrong and somehow we triggered an infinite loop. Let me just check. So if, okay, so since we are not putting this condition above, we have to put this condition above of the continue, otherwise we will get into the infinite loop. So now let's see. You can see 1, 2, 3, 4, and 5. So we are getting all the values from 1, 2, 3, 4, 5, but this doesn't make sense. So how do we use the continue statement? With the continue statement, we can stop the current iteration and continue with the next. Okay, so it says while I, okay, let's just copy this example and let's see how it works. So we have I equal to 0. Now while I is less than 6, so I plus equal to 1. Okay, so I plus equal to 1. If I equal to 3, then I want to continue. Otherwise, I want to print I. So let's see what do we get. So now it works. Okay, the reason why it was not working earlier because I put the print statement above the if condition. So earlier we were doing something like this. Now this will of course not work because we are checking the condition here. So the I is getting printed before we are using the continue statement, and that's why when we'll print this, you can see that we are getting 1, 2, 3, 4, 5. Now this thing should come after the continue statement. like this. And now you can see that we have skipped 3. With the else statement, we can run a block of code once the condition is no longer true. Okay, that's interesting. So in Python, we can use the else statement to run a particular block of code when the loop has ended. So we in Python, we just don't have if else, we also have something known as while else. So we can do while else. So if I run this, I should get I is no longer than 6 when the loop ends. Great. Now let's come on to the for loops. Now we have used for loops a lot in all the previous sessions. So you just have to use for an iterable and then in, sorry, a variable in and then the iterable. So that's the syntax. We can use that in iterable, we can use that in strings. Again, we can use the break keyword and the continue keyword in for loop as well. We can also use the range function. We have already seen that to make the iteration in a particular range. We can give the start parameters and the end parameters. Okay, we can also use the range function to give a increment value. For example, something like this. So here you can see that we are saying x in range 2 to 30. So obviously 2 will be inclusive, 30 will be exclusive, and we want to increment by 3. So we can specify this as well. Nice. So if I run this, I should get all the values starting from 2, but the increment will be by 3. So 2, 5, 8, 11, and so on. Again, interestingly, we have a else statement in Python. So we can do something known as else and do something like finally finished. So I can say print finished. So the else statement can be used to execute a block of code after the for loop has been finished. So in Python, we can use the else statement after the while loop and after the for loop as well. So if I run this, we should get finished at the end. You can see finished. Great. Now, of course, we can do nested loops like we do in other not visible character. Okay, I didn't understand what you want to say exactly. Which character is not visible? I'll do I need to zoom in on something or something like that? I think everything is visible. Can you please clarify, Narendra? And thank you so much for interacting. Please hit the like button if you're watching. Please write yes in the comment box if you're understanding, or no in the comment box if you're not understanding, and just ask me anything if you want to know. Okay, so as I told you, we can create nested loops. We can use the pass statement similarly as we used in the if statement. So we can use the pass statement in the loops as well if we want to keep the loop empty. Otherwise, the loops cannot remain empty in Python. Same as the case with the if statement. The if statement cannot remain empty, the loops cannot remain empty. If for some reason you have to keep the loop empty, you have to use the pass statement. Okay. Now let's come on to functions. A function is a block of code which only runs when it is called. A function can return data as a result, and it helps to avoid code repetition. So just let me comment this thing out so that we are not running the loop every time we are running our code. just comment this. Okay, now let's come on to functions like this. So we can create function in Python using the def keyword followed by a function name and parenthesis. So this is how you create a function in Python. So this is how you create a function in Python. So I've created my function and we have written some print statement in it. Now to call a function, we have to write the function name with the parenthesis. This is how you call a function. As simple as that. Generally similar in most of the programming languages. If I run this, you can see that we are getting hello from a function here. You can call, of course, call the same function multiple times. So no matter how many times we call this, every time the code will get executed. And this is how we don't repeat the code. So we don't have to write print hello from a function again and again. We can just call the function or write any block of code and we can call the function and that block of code will be executed. Now, there are a few rules which we have to follow while writing the function name. So it must start with a letter. Okay, just write, let's write this so that it remains in this particular file. Okay, so these are the rules while defining a function name in Python. So a function name must start with a letter or underscore. It cannot start with a number. It can only contain letter, number, and underscores, and they are case sensitive. So my function like this and my function like this are different. So these are three rules which you have to pay attention to while writing in Python. Now the function can return values as well. So they can send data back to the code by using the return statement. What I mean is, let's take an example. So instead of this, we can do something like this. So we can say get greeting and we're returning a string here. So we can store that particular string which has been returned from the function in another variable and we can use the variable in the way we want. Here we are printing it, but we can use it in the way we want. And we can just use the return value directly. We don't need to necessarily store it in a variable. Even if we write something like get greeting here directly, this will also give me the string which I am returning from the function or any value which I am returning from this particular function. Now again, the function definitions cannot be empty. So if I just remove this statement, I should get an error. You can see, okay, let's remove this. And you can see that we are getting an error that this function is empty. So for development purposes, if you want to keep a function empty, you have to use the pass statement. And then you can see that we are not getting any error. Generally, function, the if statements, the loops, they are not to be kept empty in Python. If for development purposes or for some reason you need to keep it empty for some time, you need to use the pass statement for the code to execute. Now let's come on to function arguments. Now information can be passed to functions as arguments. Arguments are specified after the function name inside the parentheses. So here we specify the arguments. You can add as many arguments as you want, just separate them with a comma, of course, as in most programming languages. So we can say A, B, C, something like that. These are all the arguments. Now let's take an example. So if I just copy and paste this, you can see that I have created a my function named my function, and here we have the argument f name. Now we can see print f name and some random string. Now if I pass different values in this argument, now these values are known as parameters. If I pass different parameters in our function, this argument will take it and we will get this particular name with this string. Let's see this in action. And you can see that here we are getting all these values with the same string. By default, a function must be called with a correct number of arguments. So if your function expects two arguments, you must call it with exactly two arguments. What does that mean? It means that if I have defined two arguments here, then two values should be defined in the function call as well. Here we are using one argument, so one item has been defined in the function call. So this is important. Okay. If you try to call the function with the wrong numbers of arguments, you will get an error. For example, if I do anything else, for example, write Tobias here, we will get an error like this. You can see my function takes one positional argument, but two were given. So we cannot do this. Now we can assign default values to the parameters. If a function is called without an argument, it will use the default value. So here, if I say something like friend, so this is how you use a default value with the function argument. So here we have given a default value of friend. So whenever I will call a function without any parameter, so if I do something like this, then friend will be used instead of an empty value. So if I do something like this, you can see we are getting friend here, and for the rest of the two function calls, we are getting the value which through which we have called the function. You can also send arguments with the key value syntax. Okay, so let's take this example. So you can see that here we have my function and then it takes two arguments, animal and name. Now we are printing I have animal and my animal's name is the name. Now we can use the key value pair in the function call. So we can say animal equal to dog, name equal to buddy. And using this way is advantageous because you don't have to care for the order of the uh, parameters while calling the function. So for example, if you have like 10 different arguments in the function definition, so while writing the function call, you have to specify every parameter in the exact order. If you don't want to remember the order, if you are unsure of the order, so the easier way is just to give it as a key value pair with a equal to sign, and it will automatically take care of the order. Now, when you call a function with arguments without using keyword, they are called positional arguments. So, as we have seen also, we got an error that incorrect positional argument. So, whenever we are calling the function without any key value pair, so if I am doing just something like this, these are known as positional arguments and they must be in the correct order. So I cannot do buddy before dog. So of course I can do that, but then we will have a semantic error, or basically the animal will get buddy and the name will get dog. Mixing positional and keyword arguments. So we can mix the two as well. So, for example, if for some items I am sure of the position, I can have them without any key value pair, and for other items, we can define the key value pair as well, like this. So, this is also perfectly fine. So, we can do anyways. So, we can use just the positional arguments with the correct order of the arguments. We can do only the key value pairs, in that the order does not matter, or we can mix and match both of them. In that case, whatever item or whatever parameter we are defining in the function call should be at which is without any key, should be at the correct position, and rest of the items can be with the key. For those items, the position does not matter, or the order does not matter. Now, passing different data types, you can send any data type as an argument to the function: string, number, list, dictionary, etc. The data type will be preserved inside the function. Now, again, we can return the values, we can return computed values as well while defining a function, and we can return different data types as well. So earlier we had seen that we returned a string, so we can return any different data type, for example, list, dictionary, tuple, etc. Positional only arguments. So you can specify that a function can have only positional arguments. Okay, this is interesting. So let's understand this example like this. So you can see that I have written a slash here. So this means that only positional arguments are allowed. We cannot use the named or the key value arguments like this. If I use something like this, I should get an error. Let's see that. You can see my function got some positional only arguments passed as keyword arguments name. So we cannot use this. Whenever we are using slash, we just have to use the positional arguments without any keywords. Basically, we have to maintain the order while passing the arguments. Now, if you want to have only keyword arguments, you can use a star instead of the slash. So instead of the slash, we can do star like this. And now we will only have keyword arguments. If I try to run this, I should get an error. You can see that takes zero positional arguments, but one was given. So it does not take any positional arguments. But if I do something like name, then it will not give me an error. You can see now the code works perfectly fine. Okay, we can also combine position only and keyword only arguments. So anything before slash will be position only, and anything after the star will be keyword only. So we can do something like this. Let's replace all of this, and we can do something like this. So we have here, for example, four arguments in the function call. Now, everything before slash is mandatorily positional, and everything after the star is mandatorily keyword arguments. So I have to write 5, 10, C, 15. I cannot mess with this, otherwise it will give me an error. Okay, args and quarks. By default, a function must be called with the correct number of arguments. However, sometimes you may not know how many arguments will be passed in your function. Of course, that is the case sometimes, that we don't know beforehand how many arguments has to be passed in the particular function. So args and quarks allow the function to accept an unknown number of arguments. Args are basically arbitrary arguments. So if you don't know how many arguments will be passed to the function, add a star before the parameter name. This way, the function will receive a tuple of arguments and can access the items accordingly. Great. So let's understand this. This is important. Args and was something like this. Now let's take this example here. Now you can see that I don't know how many arguments are going to be required for this function. So I can just pass a tuple of all the values, or I can just pass in all the values and it will be received by kids as the tuple, and we can use the square bracket syntax to access any value from the particular tuple. Okay. The args parameter allows the function to accept any number of positional arguments. Inside the function, args becomes a tuple containing all the past arguments. Okay, as we have told. So this will become a tuple and it will be received by kids. So kids equal to Emily, Tobias, Linus in a tuple or in a parenthesis. We can also combine args with normal parameters. So for example, we can do something like this. So I can do something like this, and this is perfectly fine. So we can say greetings and then names. So we have to mandatorily pass a greeting, and then names can be all other values after the particular greeting. So hello, so greeting will receive the value of hello, and names will receive a value of all other values as a tuple. Great. So args is very useful when you want to create flexible functions. Of course, in real world cases, multiple times we don't know how many parameters how many arguments we need in the function. So this is very helpful in that. Now, similar to the arbitrary arguments, we have arbitrary keyword arguments or double star quags. So when we use something known as quags, then we create a arbitrary keyword argument. So let's see an example of this. So if I create something like this, you can see that the kid is an arbitrary keyword argument. In this, we have to specify the keyword for each argument while defining the particular function, and then it will be used in the same way. So we can use kid L name or F name the way we want to do it. The quarks parameter allows the function to accept any number of keyword arguments inside the function. Quarks becomes a dictionary containing all keyword arguments. So that's important. So while using args, it becomes a tuple of all the parameters, and quarks, it becomes a dictionary of all the parameters. Interesting. So this is something which you want to remember. So whenever you use args, everything becomes a tuple or basically a ordered list, which we can access through a square bracket and the index number. And whenever we use quarks, it becomes a dictionary or a key value pair because the keys are mandatory while using the quarks. And again, we can also use quarks with a regular keyword. So we can use regular parameters or regular arguments as well as quarks. So everything in the regular argument will be passed as basically a simple parameter, and for quarks we have to define the keys. Now we can also use both the args and the quarks. So let's take this example like this. So here we are using title, args, and quarks. So user info will go into the title. Everything after that, for example, Emily, Emil, and Tobias, this will go in args as a tuple, and age and city will go in the quarks as a dictionary. Very important to understand, grasp this slowly. The user info will go in title. Args will have the positional arguments, all the arbitrary arguments after user info. So basically Emil and Tobias. And this will have all the keyword arguments. So basically age and city. So if I run this, let's see what we get. You can see title is user info, positional arguments Emil and Tobias as a tuple, and keyword arguments are as a dictionary. Now, unpacking arguments. The star and double star operators can also be used when calling functions to unpack, expand a list of dictionary into separate arguments. Okay, so if you have values sorted in a list, you can use star to unpack them into individual arguments. Let's take this example, unpacking arguments. Okay, okay. So here, my function, three arguments, ABC, numbers is equal to 1 to 3. So numbers is a list of three items. Now, what we are saying, result equal to my function, we are calling the function, and then we are using star numbers. So basically, the numbers will be unpacked and each value will go to each argument in the function call, in the function definition. So 1 will be assigned to A, B will get the value of 2, and C will get the value of 3, same as my function 1, 2, 3. Okay. So if you want to unpack dictionaries, you have to use double star. Great, very important, very interesting. Single star for all the ordered iterables and double star for all the unordered iterables or the dictionary. So we can use something like this. And you can see that we have my function, then we have two arguments. Now we have a dictionary of these two items, and we can say my function and star star person. Same as my function, f name is equal to ml and l name is equal to restness. Now let's come on to scope. A variable is only available from inside the region it is created. This is called scope. So we have already learned that a variable is only accessible, like if a variable is defined inside the function, it is accessible only inside the function. So that is known as local scope. If I want to create a global variable, either we have to create it outside the function or we have to use the global keyword. This we have already learned earlier. Okay, one interesting fact here, the non-local keyword is used to work with variables inside the nested functions. The non-local keyword makes the variable belong to outer functions. Makes the variable belong to the outer function is used to work with variables inside the nested function. Okay, so let's take this example and run this. So if I do something like this, so if I say def myfunc x is equal to Jane, we define another function inside the function too, and we say non-local x. We change the value of x. Let's see what happens if we call the my function. Okay, let's save this and let's run it again. Okay, so here you can see that we are getting hello. So since you are using that keyword non-local, so the value of x of the outer function is getting changed. If we don't use this non-local syntax, then you can see that x, we are not actually using x. So basically this x is only accessible in my function or the outer function. It is not accessible inside. The same x is not accessible inside the inner function. So if you want to access a outer function inside a inner function, we have to use the non-local keyword. Let's write this down. To access the variable of the outer function. Awesome. Now, what are Python decorators? Let's learn decorators. Decorators let you add extra behavior to a function without changing the function's code. A decorator is a function that takes another function as an input and returns a function. Basically, if you are coming from a JavaScript background, higher order functions, as I understand, that is decorators in Python. So we have to define a decorator first and then apply it with at the rate decorator name above the function. So let's see the syntax. We can do something like this. So we have defined a function change case and now it receives a function. Now we have defined another function inside it, my inner, and return func.upper. So whatever is coming inside the func, it is returning with dot upper and then return my inner. Now we can use the decorator with at the rate. So at the rate change case, then use the function. So here we have defined the function, my function, hello Sally. Now, if I call only the my function, automatically the change case will be called and hello Sally will be received in func, and then it will go into the my inner and it will return the uppercase value of this complete string, and we're returning the inner function. Let's run this and we should get hello Sally in uppercase. So this is important to understand. Please grasp this and type yes in the comment box if you are understanding what is, if you're understanding what the decorators are doing or how to use the decorators. By placing change case directly above the function definition, the function, my function, is being decorated with the change case function. The function, my function, is the function that gets decorated. Okay, so wherever you're using the decorator, the function just after that, that is the function which is getting decorated by the function which is defined with the at the rate. So here, my function is getting decorated with change case. A decorator can be called multiple times. Just place the decorator above the function you want to decorate. Okay, so we can just do something like this, and it is perfectly fine. So we can just create a decorator and you can use it with any function which you want. If we call this, we will get the same result. So both this I am Speed and Hello Sally should come in uppercase as expected. Okay. Arguments in the decorated function. Functions that require arguments can also be decorated. Just make sure you pass the arguments to the wrapper function. Okay, so let's take this example here to understand what is this or how to use decorators with the parameters or with the arguments. So you can see that we have defined a decorator here, change case. It is accepting a function. Now inside this we have an inner function x and we are using the upper method on that particular function. Now we are using the decorator here. Now def my function name return hello plus name. So when I pass it in this return value, this complete value will go in that in the change case function or the decorator, and it will be evaluated with the upper method and we will get the uppercase syntax. So this is something which you need to understand if you want to use the decorators effectively. And you can also use the args and the quarks method inside the decorator as well. So the decorator function has no control over the arguments passed from the decorated function. To solve this problem, we can use the args and quarks to the wrapper function. And this way, the wrapper function can accept any number and any type of arguments and pass them to the decorated function. Great. Decorator with arguments. Decorators can accept their own arguments by adding another wrapper level. Okay, so if you want to pass arguments in the decorator, we can add another wrapper level and then pass those arguments to that wrapper level. For example, let's take an example here. And you can see that we have uh, change case n. Okay, so change case is the decorator, which is receiving an argument. Now inside this we have another change case function. So this is the decorator. This is the wrapper outside the decorator, which is accepting an argument. We have an inner function, and we are saying if n equal to 1, then change it into lowercase. Otherwise, change the return value of func in uppercase and then return whatever a is, finally return my inner, and finally return change case. So this is interesting. So we can say change case 1. So if I pass change case 1, then it will change the function to lowercase. If I say change case and if I don't pass 1 in it, it will change to uppercase. Interesting, really interesting. So this is how you can control the decorator function to do multiple values or basically pass an argument to the decorator function for creating different kind of outputs. You can also use multiple decorators on one function. This is done by placing the decorator calls on top of each other. Decorators are called in reverse order, starting with the one closest to the function. Okay, so this is important. Decorators are called in reverse order with the one closest to the function. Okay, so we start with the starting with the one closest to the function. Okay, let's understand this example. This will give you a great insight on the working of decorators. So here we are using two decorators. So change case is one decorator which is accepting a function and changing it the whatever the return value of the function passed into uppercase. Then we have a add greeting decorator, which is adding some string value to the return value of the function. So hello and have a good day is being added by the add greeting decorator. We can use both these decorators together in the my function, and it will first call the add greeting decorator, then it will then it will call the change case decorator. So if I say return Tobias, so it will first add the greeting, so it will say hello Tobias, have a good day, and then it will change the function to the uppercase. Okay, so this is how you call or use the decorators. Functions in Python has metadata that can be accessed using the name and the doc attributes. Okay, normally a function's name can be returned with the name attribute. Okay, great. So function metadata. So we have something known as name and doc. So if I do something like this, we can get the name of the function. We should get my function on the console. You can see my function on the console. So if I do double underscore name double underscore, we get the name of the function. But when a function is decorated, the metadata of original function is lost. Okay, that is important. Function metadata is lost when a function is decorated. Great. To fix this, Python has a built-in function called functools.wraps that can be used to preserve the original function's name and docstring. Okay, so let's understand what we mean by this. Okay, let's wrap this. Okay, so let's do another line. So to fix this, Python has a built-in function called functools.wraps. So we can use functools.wrap to preserve the function metadata while using it with decorators. Let's understand this with an example here. So I can do something like this. So import functools, the def change case function. So change case is the decorator. And inside this, we are using @functools.wraps. So this is something which is provided by Python to preserve the metadata of the function. Then we call the inner function or define the inner function, and we change the case, return the inner function. Now we are using the decorator, and if we use my function.name, so let's first run this. Let's see what happens. And you can see we are getting my function. Now if we remove this, so if I remove this statement, now if I run this, you can see that we are getting my inner. So the function name is changed to my inner or this function. So basically the original function's metadata has been lost. If we don't want to lose it, we have to use functool.wraps. Interesting. Now, the next is lambda functions, very important of very widely used in Python. So we say lambda functions. Okay. So lambda function is a small anonymous function. A lambda function can take any number of arguments, but can only have one expression. So lambda function, it can only have one expression. So let's see how to define a lambda function. So we can say something like this. So we can say x is equal to lambda a. So this is a lambda function, and here we are putting a colon and then putting just one expression which the lambda function can take. So a plus 10. So basically any value which will be coming to x will be incremented by 10. So if I print this, we should get the value of 15 as expected. We're getting the value of 15. Lambda function can take any number of arguments as already told. So let's take another example. If I do something like this, x is equal to lambda ab. So here we are giving two arguments. So we are giving 5 and 6, and we are multiplying both of the numbers. So we should get the answer as 30 on the console. So this is how you use lambda function, very widely used. Everywhere you use the syntax to make the Python code smaller and sharper. The power of lambda is better shown when you use them as anonymous function inside another function. Say you have a function definition that takes one argument, and that argument will be multiplied with an unknown number. So something like this. Very important syntax. Understand this carefully. So here we have created a function myfunc with an argument n. Now we are returning lambda a into n. So here we are creating a lambda function with an. So now if I want to use this, this is how we will use this. So this will become my. So I have created a my doubler, my func 2. Now everything will be multiplied by 2. If I want to create my tripler, so we just have to say my func and 3. So we don't need to even define the function again and again. We just can say my func 2. This will be my doubler function, and it will double all the items which I give it to it. If I create a my tripler function or whatever name, the name is immaterial here. If I create it with my func the argument 3, then it will create a tripler function. Now whenever I call this, we just have to give it one value and it will do the job. So this is very interesting. Type yes in the chat box if you understood what I'm saying here or what the lambda functions are. Or if you want me to explain again, just write in the comment box or the chat box. Or use the same function definition to make a function that always triples. Okay, great. As I showed you. Lambda with built-in functions. Lambda functions are commonly used with built-in functions like map, filter, and sorted. The map function applies a function to every item in the iterable. So similar to the map function in JavaScript, something like this. Now we are getting into some advanced stuff in Python. So if like you guys are watching and if you are thinking that AI can do all the coding, why I should learn how to code in any particular language. So to write better code or to understand what AI is giving, you need to understand. So AI will give you something like this. Now, if you want to make some minor tweaks or minor changes, or you just want to explain the code to someone, you will not be able to do so if you don't have the basics. So that's where it is very important to understand the fundamentals of any programming language so that you will be able to use AI more efficiently to produce better code. Okay, so extrovert bro, sir, can you define class? Yeah, we will be coming on to that. So probably next or probably after that, we should be jumping on to Python classes that has been created. I also want to learn that. So we will do that together. Python classes probably in the next live stream, probably tomorrow or day after, or in the next one to that. So probably in the session 5 or 6, we will move on to the object-oriented programming in Python, and we will do all the classes and stuff like that. Okay, so tell me if you understood the lambda function or not. So this is how you create a lambda function. Now, as I told you, you can use the lambda function with map and filter or sorted or other built-in function Python methods as well. So here you can see that we have created a list, numbers is equal to 1, 2, 3, 4, 5. Now, list map. So list is the constructor we are using to create a list. So this will give another list to us. Map iterates over all the items in a particular uh, in the given list or any given iterable. Then inside this we are using the lambda function to perform one single operation or one single expression, and here we are providing the list on which we want to map. So numbers lambda x into 2. So all the items will be taken, it will be multiplied by 2, and it will be created as a list. So if I print doubled, we should get 1 into 2, 2 into 2, 3 into 2, and stuff like that. Let's see that in action, and you can see 2, 4, 6, 8, 10. Great. Great. Thank you so much, Kaggle Mane. And what inspired you to watch this? Okay, so YouTube recommended this live stream to you. So are you enjoying it? Like, how do you're working as a tech lead? Yeah, I also work as a tech lead. I'm teaching the basics here. We will go into some advanced stuff as well someday. Yeah, but like, tell me about your organization. Like, how do you do? How do your developers code? Or if you do some coding, like, how much AI you're using in coding at your organization, or you're not using AI at all, or you're just stuck to GitHub Copilot, which is given by the organization, something like that. Something you can tell me that how things are on the AI side in your organization. Okay, so similarly, we can use the filter function that creates a list of items for which the function returns true. So we can similarly, so instead of map, we can use the filter. We can apply any kind of filter using the lambda function. We have to give one expression, and that will just filter the items on those particular things. Can you give example how we can use def function in lambda function? Okay, I think we have given example here. So this is how you do it. So we have created a function with using the regular def keyword, and inside this we are using the lambda function. So anything which is coming, so this is used when you want to create multiple functions. For example, if I want to create a my doubler, my tripler, so multiple functions like that. So what we can do, my func2, my func3, my func. So if I want to create a function to multiply something with 5, you can just say that my func5, and I'll have a function which can multiply my values with 5. Let's go over it again. So what we are doing, we are creating a function with an argument n. Now we are saying the lambda function will take a value a, and a is basically the argument, and whatever argument it will receive, it will multiply it with that particular value n. So when I created my doubler, I said my func2. So n equal to 2. So what we are getting? We are getting the return value of, so this becomes equal to lambda a colon a into 2, something like this. Okay, that's it. Now, when I'm calling my doubler with 11, a gets the value of 11, and we are getting the value of 22 here. I hope I have made myself clear. Like, if you understood this, write yes. Tell me that you have understood this. We sometimes use AIs to help with the coding snippets, documentation, but we always suggested people to use it only when necessary. It shouldn't stop us from creative thinking. We mainly use C sharp. Of course, I'm of the same opinion, but probably the world is not of the same opinion. I'll be creating a video soon on the relevance of AI, and I'll not be putting my opinion in it. I'll just put the research, which is like what the top people in the field are saying about this, because we're already moving towards a world where AI is going to do everything, like all the code. Yeah, but my view is that we need to understand the code. We need to have the control over the code. Even if the AI writes it, we should know line by line what has been written, why has been written, so that we can fix any security, because AI right now, at least at this point, gives really insecure code. So that is my point of view. But you just can't help it. Like things will move on to AI, and AI will write every code. Creativity is probably dead soon. I don't know. Like that's just my opinion. I can already see a lot of people uh, just just using AI blindly. So let's see how it goes. Okay, explain recursion and decorator also. Recursion, yeah, we are getting onto recursion. Decorator, you want me to go over it again? So we can go do a quick overview of decorator. So basically, decorator is a function which takes another function. So if you are from a JavaScript background, it is something like a higher order function. So here you can see change case is a decorator which takes a function. Okay. Now, whatever the return value of the function is, it is passed in the inner function. So decorator is the wrapper function. Inside this, there's an inner function which we have to define, and whatever the operation is, it will be applied on the return value of func. So for example, here we have, and to use the decorator, we have to use it with at the rate and the name of the decorator. Okay, just before the function. So I'll go over it again. So here we have defined a function, my function, which returns a string. Okay, return my string. So we have a function, it returns a string. Use the decorator above this function with at the rate, like this. Now, this value, the return value of it, have a great day, goes here in change case. It goes inside the inner function, and it the upper method is applied on the return value, and we get have a great day in uppercase. That's it. That's how you use decorators. Now, func tool wraps, again, this is something which I explained, that the functions have metadata and it is lost when a function is decorated. So we can use func tool wraps to preserve the metadata of the function. Great, great extrovert bro. Thank you so much. Thank you so much. I hope you have liked the live stream. I hope you have subscribed, and I hope you're enjoying the live stream. So, and I think I have told you how to use the decorators. Now let's move on to recursion. Recursions. One of the most dreaded topic of all the programming languages, recursion. Like, let's go over it. So recursion is when a function calls itself. Recursion is a common mathematical and programming concept. It is prevalent in all the programming languages. It is asked in all the major exams, the DSA, everywhere. Recursion is something which is uh, asked repetitively, and so we will go over it very slow. So recursion is a common mathematical and programming concept. It means that a function calls itself. This has a benefit of meaning that you can loop through the data to reach a result. Now, again, it here also we have a caution. The developer should be very careful with recursion, as it can be quite easy to slip into writing a function which never terminates, or basically creating an infinite loop with recursion, or one that uses excess amount of memory or processing power. However, when written correctly, recursion can be very efficient and mathematically elegant approach to programming. So let's create a simple recursion function. So this is a very simple recursion function. So we're defining a countdown function with the argument n. Now, if n is less than 0, this is the condition which we are giving to terminate the loop. We have to print done. Otherwise, we have to print n. And then we have to call the function again with a reduced value. So this is very important in recursion, that whenever you call the function, you call it with some value in which it changes the original argument. So when I say countdown n minus 1, so every time, so like for example, if I call the function with countdown 5, so 5 will go inside. Now 5 is not less than 0, so it will go on to else, it will print 5, and then it will call the countdown function with 4. Then again, same thing will happen. It will call the countdown function with 3, 2, 1, 0, and when it is equal to 0, it will print done. So this is the basic principle of recursion. This is how the recursion works. If I run this file, you can see 5, 4, 3, 2, 1, done. Every recursive function must have two parts, a base case and a recursive case. Let's write this. Very important. Every recursive function has two parts, base case and a recursive case. Recursive case. So these are the two important things which any recursive function should have. This is the condition which stops the recursion. This is the condition which stops the recursion. Okay. And this is the function calling itself with a modified argument, which I was already talking about. So recursive case is the function calling itself with a modified argument. So this modified argument term is very important, that you have to modify the argument when you call the function again, so that we ultimately arrive at the base case. So here you can see this is the base case, and this is how we are calling the same function with a modified argument. And both the things are crucial, very crucial, because if you will not take care of this, you will either go into a, a infinite loop, or again use excessive memory. Okay. Yeah, anytime, anytime. Extrovert bro, whatever your name is. Thank you so much. Thank you so much for the chat. And I hope you have liked the live stream. I hope all those you're watching, please subscribe to the live stream and tell me in the comment box if you are understanding the way I'm teaching. If you have any feedback, if you want to learn something, just write in the comment box. Now let's come on to generators. Okay, so let's come on to generators. Generators is a function that can pause and resume their execution. When a generator function is called, it returns a generator object, which is an iterator. The code inside the function is not executed yet, it is only compiled. The function only executes when you iterate over the generator. Okay, let's understand this. So let's take an example. So here we have defined a generator. This is the syntax of the generator. We have to define generator, and then we say yield 1, yield 2, yield 3. Now, when a generator function is defined, it is only compiled. It is not called. The code is only executed when you loop through the iterator. Okay, so for value in my generator, so when I'm doing this particular thing, then it is getting executed. If I just comment this out, and if I just call the myGenerator function like this, sorry, if you don't use semicolons in Python, okay, you can see nothing happened because the code is just compiled. The code will be executed when we use it with a iterator like this. Now, if I run this code, we should get 1, 2, 3 here. Generators allow you to iterate over data without storing the entire data set in memory. So instead of using return, generator use the yield keyword. Okay, so here you can see that we are using the yield keyword, and this is the advantage of generators, that this is not stored in the memory. It is only compiled. It will be stored in the memory only when it is used with something like this. The yield keyword is what makes a function a generator. When a yield is encountered, the function's state is saved and the value is returned. The next time the generator is called, it continues from where it left off. Okay, as I told you, that the generators can pause and resume the code. So let's understand how that works. So if I say something like this, so here we have defined a generator count up to n. Now we say count equal to 1, while count less than equal to n, yield count, okay, not return count, yield count. And that is what makes this count up to n a generator. Count plus equal to 1. So for num in count up to 5, we say print num, okay. So now if I print this, you can see that we are getting 1 2 3 4 5. Now whenever we will call this generator again, it will resume from where it left off. So that is a property of generator. Return terminates the function, yield pauses it, and it can be called multiple times to, for example, if I say probably something like that 7 or stuff like that, you can see that we are getting 5 1 2 3 4 5 6 7. Okay, so this is how you use a generator function. We can also manually iterate through a generator using the next function. So for example, let's see this. So you can see that we have created a generator, simple generator, yield, and we are yield, in the yield we are giving three names. Now we are using print using the next keyword. You can manually iterate through the generator. So we have to use call the generator through a variable, and then we have to use the next keyword to call the iterable from the generator. This is how use you manually iterate over the particular generator. Similar to list comprehensions, you can create generators using generator expressions with parentheses instead of square brackets. Okay. Okay, so we can use the parentheses to create a, so this is how you create a generator. So if we use the parentheses, then it creates a generator. So this is the generator expression. So this syntax is known as generator expression. So earlier we have already seen something known as list comprehension. So this was the list comprehension. So we can use the square brackets, and inside this we can define an expression to create a list. Similarly, we can use the parenthesis to create a generator uh, using just one single syntax. So this is the shorthand for creating a generator. Okay. Now there are some inbuilt methods with which we can use with the generator. For example, there's a send method and there's a close method. The send method allows you to send a value to the generator. So for example, if I create a generator like this, so here we have created a generator echo generator and we are saying while true received is equal to yield and we are printing received. So we are setting a variable equal to echo generator, then we are using next gen. So basically using the next keyword to prime the generator or start the generator, and then we can use gen.send hello, gen.send world. So this all of these items will be stored in the generator. So hello and world will be stored in the received function in the generator. Similarly, we can also use the close method to stop the generator. So what we can say, we can also say something like this. So here we have defined mygen, then try yield 1, 2, 3, and then finally generator closed. So gen print mygen, print next gen, and then gen dot close to close the generator. So that is how you use generators in Python. And we have come to the end of this live stream. In the next live stream, we will learn about range, arrays, iterators, modules, data, and some math operations in Python. So, and after that, we will come on to the object-oriented programming and classes and stuff like that. Thank you so much, and thank you so much for watching till the end. And if you have not yet liked the live stream, please please subscribe to the channel, and we will do the next live stream probably tomorrow or day after, whenever I get some time. Till then, see you. Take care. Bye bye.